Okay, this is grade 11 pre-cal, lesson 2, arithmetic series. So as we did on lesson number 1, arithmetic sequence was just a series of numbers that have a common difference. Well, now what we want to do is we want to know, okay, if we have this sequence, can we add it up? What's the total? What's the sum of all this stuff? So just introducing two new formulas here. So S of n, that's the new one here, is the sum of the first n terms. N is just the number of terms, T1 is the first term, D is the common difference. Now there's two formulas here and you can use either one depending on the situation. If you know the first and the last term, you can use the second one. Other than that, you're probably going to use the first one like 95% of the time. Okay, so what we're going to do is we're going to do this example up here, the 2, 5, 8, 11, 14. We see it as a common difference of 3. Okay, so let's go to second page there and let's do this example. So from that one, what is the sum of the first 15 terms? So we know n is 15. The first term is 2. The common difference is 3, right? We just plug it into the formula. S of 15 is what we're looking for. And we find the sum of the first 15 terms is 345. But then I could ask you, hey, I could ask you a single, next part of the question, what is the 15th term? So then we have to go back to this sequence formula that we used on the previous lesson. So it's this formula right here. We plug in, we're looking for the 15th term. So we know T1, we know 15, we know D, we plug it in, we end up with 44 as the 15th term. I mean, you could brute force this, right? You could go through here and go 2 and 5 and 8 and 11 and 14 and 17 and 20 and do that, but that's a waste of time, right? If you use the formula, you can figure this stuff out pretty quick. Okay, so let's look at example, actually, let's jump to example 3 first, and then we'll come back to 2. Example 3 is, it's a theater. It's got 22 seats in the first row. And then every row after that, we add 2 more seats because it goes up kind of like a pie shape, right? So people can see the front of the theater. So we know a couple things. T1 is 22. D is 2 because it goes 2 more seats every time, so there's a common difference. Now, if there are 17 rows in this theater, we can find out then what is the seating capacity of this theater, which is useful information because then you know how many people you can, or how many tickets you can sell. Okay, so we just use the formula again. S of 17 we're looking this time. N is 17, T1 is 22, D is 2. Okay, we plug it all in, we can find out, 646 people can fit in this theater. Okay, now, let's say you decide you want to take your family, and that includes everybody, you know, grandparents and cousins and everybody, and you want to know, you want to sit all in the same row, and you decide, okay, I want to sit in the 12th row. So what I need to know is how many seats are in the 12th row to accommodate my entire family. So here we go. So then we go back to that formula again, the first one, the sequence formula. Looking at the 12th row, right? T1 is still 22, N is 12 in this case, and common difference is 2. Okay, so then I can figure out, do the math here, that in the 12th row, I can put 44 people. I'm perfect. That's exactly how many tickets I need to buy, so we can all sit together in one row. That's what that's for. Okay, so let's go back to example number 2. And the reason we skip that is it's quite a bit harder because it has to do with systems of equations. So what we have here, and this was actually from one of the questions in the textbooks, the sum of the first 2 terms of an arithmetic series is 13. And the sum of the first 4 terms is 46. So what they do is they give you 2 pieces of information. So we're going to use the summation formula because it says the sum. So this first one, the sum of the first 2 terms, right, is 13. So the sum of the first 2 terms is 13. N is 2 because it's telling you that, but we don't know what T1 is. We do not know what the first term is. N is 2, and we don't know what D. So if you look, we have 2 unknowns. So now you can see why this is going to be systems of equations. So what we do is we're going to rearrange this first one so D is by itself. So to get rid of the 2T1, it's positive. We move it to the other side. We end up with negative 2T1. Okay, so this equals D. Okay, so just remember that. The second one says the sum of the first 4 terms is 46. So 46 is the sum of the first 4 terms. 4 terms is N, so the 4 is N there. We still don't know T1. We know N again, but we don't know D. So again, we got another one where we don't know what T1 and D is. Okay, so let's simplify this a bit. We divide both sides there by 2. We end up with 23 equals 2T1 equals 3D. Move the 2T1 over to the other side, it becomes negative, and we divide by 3. And the reason we did that is, look, we have this equal to D. The same as this one up here, we have it equal to D. So this is substitution from systems of equations. So they both equal D. Therefore, over here on this side, we could say, yep, they both equal each other. So we set that over 1 equal to that over 3. How to solve this? Cross multiply. right? You cross multiply, collect like terms, and you can figure out that the first term is T1. Now, if you know the first term, you can plug it into either one of those equations to figure out what the common difference is. It doesn't matter. Remember, that's the deal with systems of equations. You plug it in, you find out D is the common difference. So now we know the first term, and now we know that the common difference is. So then we can go along and we can figure out what all the terms are, right? We could do it like manually like this. T1 is 4, and we keep adding 5 to it. T2 is 9, T3 is 14, all the way up to T6, right? And then we could figure out, I think the question actually asks up here, determine the first 6 terms of the series. We just did that, and the sum to 6 terms. So, I mean, if you listed them off like this, 4, 9, 14, 19, 24, 29, you could just add them up. But we can also use the formula. Now, if you look at this case, we actually use the second formula because we knew the first term and the 6th term. So we can save ourselves a bit of time, right? So there's n terms, so we're finding the sum of the first 6 terms. 6 divided by 2, and 4 and 29, because there 4 is the first term and the 6th term is 29. You do the math there, you find out that the sum of the first 6 terms is 99. And you could double check that. You could add up all these 6 numbers and make sure you get 99. Okay? So that is lesson 2. What was that one again? Oops. If I can go right, lesson 2, arithmetic series, right? So arithmetic sequences was just the list of numbers, and arithmetic series is when you add them up, okay?